So question related to the electric field, capacitors, liquid crystal displays, which LCDs are made from two parallel plates, as you can see, 10 micrometer apart. So the two plates are 10 micrometer apart with the liquid crystal display, like the liquid crystal molecules are shown. The glass is coated with a conducting material which can conduct electricity. The molecules are positive at one end and negative at the other, and they are normally aligned parallel to the glass plate as shown. The switch is closed. Now we close the switch. As a result, when we close the switch, the current start to flow through. So this is a positive terminal, so this plate will be positive and this plate will be negative. Calculate the electric field strength between the plates. So the formula which we use to calculate the strength of electric field, we have the formula V is equals to ED. So the formula V is equals to ED. If we need strength of electric field, so E is equals to V divided by D. What is V here? V is the voltage which we applied, that is 1.5. And what about D? D is the distance between the plates. It is 10 micrometer, so it means it is 10 into 10 to the power minus 6. So 1.5 divided by 10 into 10 to the power minus 6. So when we divide these two values, 1.5, so it will come out as 1.5 into 10 to the power 5. And the unit of strength of electric field, it is, you can mention, because unit of voltage is volts and distance is meter, so it is volts per meter, or it is force per unit charge, so we can also say Newton per Coulomb. Then the second part, what happened to liquid crystal molecules? So what will happen to these liquid crystal molecules? As we know, the like charges repel and unlike charges will attract each other, so they will align them according to the external electric field. So originally the molecules were parallel, but as a result, what happened? Unlike charges attract, so negative part of a molecule will be attracted towards the positive plate, and positive is attracted towards negative plate. So the what will happen to the molecules of the liquid crystal? It will align according to external magnetic field, or opposite, like charges repel, unlike charges attract. So molecules will rotate or align with the field, and the positive charge will be there at the bottom and the negative charge will be there at the top. Is it clear, this one? In this question, the diagram represents a proton. So here is a proton, and draw the lines to represent the electric field. Because proton is a positive charge, the direction of electric field is always in the direction, is a force experienced by the unit positive charge or a test positive charge. So the direction is always pointing outward. Then calculate the electrostatic force on the electron in a hydrogen atom. So we have to calculate the force, and the average distance between the proton and electron is 5.4 into 10 to the power minus 11 meter. So inside the nucleus we have a proton, and outside the nucleus we have electron, and these particles, they are attracting each other. The distance between them is 5.4 into 10 to the power minus 11 meter. So distance between the and if we want that force, that is given by a formula according to Coulomb's law. that force of attraction or repulsion between the charges is given by a formula K Q1 Q2 over R square. So the value of the K is a constant here. K is equals to 1 upon 4 pi epsilon naught, or directly you can take the value of the K, which is 9 exponent 9. So the value of the K is equals to 9 exponent 9 multiplied by charge, because proton and electron, they have the same identical charge, and the magnitude of this charge is 1.6 into 10 to the power minus 19. So it will be 1.6 into 10 to the power minus 19, and divided by square of the distance between them. So the distance between the two particles, that is 5.4 into 10 to the power minus 11, and then whole square. So when we substitute these values, our force will come out as 7.9 into 10 to the power minus 8 Newton. Is it clear discussion? Because we are finding basically a magnitude. If the question was there like finding a direction, then we will substitute a negative. But we are only finding the magnitude of the force. That's why we are not substituting the sign. For electron and proton, they have the magnitude of the charge is same, the nature is different. So we are just finding the magnitude here. Is it clear? So an uncharged capacitor is connected into a circuit as shown. So you can see a circuit with a battery, a resistor, and a capacitor. Describe what happened to the capacitor when the switch S is closed. So when we close this switch S, what will happen to the capacitor? So basically, for a capacitor, from the negative terminal of the battery, electron will move from one plate to another. So one plate will become positive, another one, like there will be a, when the switch is closed, there will be a movement of electrons, and one plate will become positive and another one will be negative. So this is a positive terminal of the battery, negative. So when we connect, so when we are writing the answer, there will be a movement of electron. The capacitor plates will positive and negative. And then what else will happen? Like till what point this capacitor will charge? The capacitor will charge until the voltage of the supply, because like example, if this was a 6-volt supply, so this is a fixed resistor, so some voltage will drop here, maybe 2 volts will drop here, so remaining 4 volts will drop across the capacitor. So the capacitor will charge until the voltage of the supply equal to voltage equal to sum of voltage across capacitor and resistor. If there was only capacitor was there, like example, if we were not having any resistor in this circuit, then what happened? Example, this was not there. So if it was not there and this was a complete connection here, in that case, the capacitor will continue to charge until the voltage of the capacitor is same as the voltage of the supply. But because there is a resistor also connected, so capacitor voltage cannot be same as the voltage of the supply, because as some of the voltage will drop across a fixed resistor. So in the next part, student models the behavior of the circuit using the spreadsheet. The student uses a 100 microfarad capacitor. So capacitance is given, which is 100 microfarad, and the resistor is 3 kilo ohm. So resistance is 3 kilo ohm or 3000 ohm. The supply, the voltage of the supply is 5. That's the voltage which we supply, that's a 5 volt. And the switch is closed when time is 0. So when time is 0, the switch is closed. So the next part, explain how cell C4 is calculated. So cell C4, so how this cell C4 is calculated, because this is a charge stored, like first, or change in the charge. So how this cell C4 is calculated? So we have the formula, charge is equals, current is charge divided by time. So charge is current multiplied by time. So current is charge divided by time. So charge is current multiplied by time. The current through the capacitor, that is 0.74, and time for to calculate this charge, because charge is current multiplied by time. So the current which is passing multiplied by time interval, for how long that current is passed. So when from 0 to 1, so what is the time interval here? The time interval between each set of the result, the time interval, or delta t, is equals to 0.1. So how we'll get this value? So charge is current multiplied by time. Current is, it is in ampere, milliampere here, so 0.74 milliampere. So 0.74 milliamps, or 10 to the power minus 3, times the time interval. So time interval from 0.1 to 0.2, so it's 0.1. So when we multiply, it will come out as 74 into 10 to the power minus 6 coulomb, or it will be 74 micro coulomb. So you can see here the Q value units are given in micro coulomb, and delta Q is a change in the charge, whereas capital Q is the total charge. Like it was like having 167 coulomb charge, then the two added 111, so it become 278, then further added 74, so it turned into 352, then 352 added 49, so 401. So this is how much charge is added every interval, and Q is representing a total charge. Is it clear, this part, how we can work out the change in the charge? So to calculate the change in the charge is a current multiplied by the time interval. So in the next part, they're asking how we can calculate this cell E3. So what is cell E3? This is third row, and E. So how we get 200 and 2.78? So how we get this 2.78, this value? And this is the voltage. So we have the formula, Q is equals to CV. So Q equals C multiplied by V. So V is the voltage, which is equals to Q divided by C, where Q is the charge, that is 278 microcoulomb. So 278 microcoulomb 10 to the power minus 6 divided by capacitance. So what is the capacitance? It is given 100 microfarad. So it is 100 into 10 to the power minus 6 or 100 microfarad. So when we simplify this, 10 exponent 6 cancel with 10 exponent 6 and 278 divided by 100. So that is equals to 2.78 volts. So that, as you can see, this is a voltage which is across the capacitor, and the voltage of the supply was now not same as the voltage of the maximum voltage across the capacitor, because still some of the voltage drop across the fixed resistor which was present in the circuit. So the graph shows the spreadsheet of a current vary with the time. So how the current is changing with the time, the spreadsheet is given. Use the graph to show the time constant is approximately consistent with the component values. Basically, time constant, time taken by capacitor to change 37% of its original value. That's a time constant, and this time constant is given by R into C. So when resistance of the capacitor multiplied by the capacitance, we got the resistance of the circuit multiplied by capacitance, you get the time constant. So resistance was given in the question, that is 3 into 10 to the power 8, and the capacitance, it is given in the first part, that is the capacitance is how much? 100 microfarad. So 100 microfarad, so it will be 100 into 10 to the power minus 6. This will give us the time constant. So when we multiply this, the time constant or value of time constant is 0.3 seconds. Now what we have to do, we have to check a code, because it should be consistent with the graph. So now we have to check a graph, like it should change to 37% of its original value. So what is the original value? Original value is 1 point, each box is representing 0.02. So this is 16 point. So this is 1, 2, 3, 4, 5. Okay, 10 boxes are equal to 0.4. So each box is 0.04. So 16.1 point, this will be first box 1.64, the second box will be 1.68. So maximum value of the current is 1.68 milliampere. Now we'll find first the 37% of 1.68. So 1.68 multiplied by 37 divided by 100. And when it is decreasing, because this is 37% when it is charging, but for discharging we take 63%. So it will be 1.68 multiplied by 63 divided by 100. Yeah. So when we work out, because using a graph we have to show it is consistent. So we have the value of I naught. This is 0.3. Yeah, two things are there. When it is charging, for discharging and charging, current graph is always same. 30, when it is charging, time it will take to charge 63% of the original value, and when it is discharging it will be 37%. Yeah, we take 37% of its original value. So when we work out here, it should be consistent with it. 1.68. So we'll just substitute the values here. We have formula I is equals to I naught. So I is equals to I naught e raised to power minus t over RC. The value for R and C, that is 0.3, because the time it will take to discharge 37% of its original value. So it is 1.68 times 37 divided by 100. So it is about 0.6. So about 0.6, like 0.62 or about 0.6. So when we draw a line here, what is the time interval? Each box is representing 0.02. So this is 2.22, 2.24 and 2.26. So it is 0.26. So the 37% of I naught is equals to 0.6, and that shows that it will be 0.26 seconds. So this is, according to graph, it is about 0.26 second, and when we substitute the value on R and C, we are getting about 3. So it means it is consistent with the graph. Is it clear? When it is discharging, we take 37% of its original value, and when it is charging, we take 63% of its maximum value. Then the next part, student think that the graph is exponential curve. How would you use another graph to confirm this? How a student can use another graph to confirm that it is an exponential curve? So basically we have the formula I is equals to I naught e raised to power minus t over RC. So we have the formula I is equals to I naught e raised to power minus t over RC. Then if I take ln both sides, if I take log both side or ln both sides, so it will be ln I is equals to ln I naught, and e raised to power minus t over RC. When two numbers are multiplied in logarithm, we write them as addition, so it will be ln I is equals to ln I naught and plus ln e raised to power minus t over RC. Ln and e are anti-functions, so it will be ln I is equals to ln I naught minus t over RC. So what we can do, if I further simplify this equation, I can say ln I is equals to minus t over RC plus ln I naught. So how I can confirm that this graph is exponential? So when I take a logarithm and I plot a graph between ln I on y-axis, so if a graph is exponential change, so we will plot a logarithm graph for those quantity and it should be a straight line. So if we plot a graph for ln I on y-axis and t on x-axis, the time on x-axis, so what will be the gradient here? The gradient will be equal to minus 1 over RC. 1 is constant, R is constant, and C is constant. It means it will be a straight line. with a negative gradient, and it won't start with a origin, because there is still y-intercept is also there. As you can see, ln I naught is added there, so y-intercept is also present. So whenever we want to show that the graph is exponential, then for the same quantities, we will plot a graph for logarithm, and it should be a straight line. The quantity on the y-axis will plot a graph for logarithm. Is it clear, this question? In this question, the simplified diagram shows a DC electric motor with a split rings commutator. Consists of two copper semicircular sections attached to either end of a coil. Fixed carbon brushes rub against and make a electrical connection to split the rings. Explain why the coil turns and why it continues to rotate. Add to a diagram. To a diagram to help your explanation. So, which direction it will rotate? As this is the direction of the conventional current. So, direction of the conventional current, we'll use the Fleming's left hand rule. First finger represent towards the field, in this case pointing towards south. Second represent direction of the current, which is from D to C. So as a result, thumb is pointing as a force. So thumb is pointing down for CD and it is pointing up for AB. So which direction this coil will rotate? It will rotate in anti-clockwise if we look from this side. So explain why the coil turn or continue to rotate. So the two forces on C and D, or force on CD and AB, create a moment or turning effect. Because from C to D the force is downward and it is away from the pivot, as well as A to B the force is upward. So the force on CD and AB will create a moment or a turning effect. Rotate the coil anti-clockwise, and the coil will continue to rotate in same direction because the direction of the current reverse in the coil due to commutators. So this is what happened. Because what happened, as you can see, A and B are moving opposite to the direction of C and D, so the direction reverses here. Now once it rotates 180 degrees, so the position of these points will change. This will be B, A, and this is C and D. So first AB, when it was on the right hand side, it was experiencing an upward force, but as the coil rotate 180, now AB is on the left hand side. So now when AB is on the left hand side, the direction of the current is different compared to initial direction. So there will be a downward force on AB and upward force on CD, which cause them to further continuously rotate 180 degrees. So for the next part, when the motor is first switched on, the current is large. But as the coil turns faster, the current decreases. Explain these observations. What is the reason why the current is large and then why the current decreases with the passage of a time? So initially the circuit is having a low resistance. That's why maximum current will pass through the circuit. So initially circuit is having a low resistance. So maximum current enters the circuit. But what happened as the coil or the motor is rotating? So when the coil rotates, between the poles of the magnet, there is change in the magnetic field, or we can say magnetic flux linkage. And because of this change in the magnetic flux linkage, what will happen? The EMF will induce. So when the coil is rotating between the poles of the magnet, there is a change in magnetic flux linkage which induce EMF. And the EMF increases as the speed increases. And the induced EMF try to oppose the change in magnetic field according to Lenz's law, which produce current in opposite direction. So the current in the coil decrease, which reduce the speed. So basically what happened in the beginning, when the coil is connected here, when there's a coil, we have a motor, electrical motor. When we close the switch, the circuit is having a very low resistance. That's why greater amount of current will enter the circuit. Example, 5 ampere enter the circuit. But that 5 ampere, like as you can see here, so that 5 ampere enter the circuit, cause a rotation to this coil, and as the coil rotates, its speed increases. So that there is a change in the magnetic field for a coil itself as it is moving between the poles. So there will be a current in opposite direction. So main current is there from the battery, but due to the change in a magnetic field, there is also another current, but in opposite direction, and two currents try to oppose the change of each other. That's why the resultant current in the coil decreases. So the speed of the coil will also decrease. Is it clear, this question? In this question, a student set up a circuit as shown. This is a circuit diagram. So when the switch is at, this is a two-way switch, when it is at position X, the capacitor will charge, and when it is at position Y, the capacitor will discharge. So she moves the switch from position X to Y. So it is at position X, she moved to Y. Explain what will happen to the capacitor. So what will happen to this capacitor when the switch originally it is at position X and we move this to position Y. So at X it was charging, but at Y the capacitor start to discharge. So the capacitor will discharge exponentially over a period of time. So one mark is for mentioning the capacitor will lose its charge or it will discharge, and the second mark is for mentioning that how the charging or discharging is there. So it is exponential charging as well as exponential discharging. The next part on the axis below is sketch a graph to show how the current in the ammeter varies with time for a moment when the switch touches Y. Indicate a typical value of the current and the time on your axis, and it's of 3 marks. So we have the supply, like we have the capacitance is given, we have the voltage, so we have the formula Q is equals to CV because we have to sketch a graph for current. So what will be the initial current? How we can work out? We can also use the formula V is equals to IR. If we have, like in the beginning, what happened, because if the capacitor, like what is the maximum value of the current, how we can work out when a switch is at position X in the beginning, that the start, all of the voltage is here and the capacitor is just about to charge. So when the capacitor is about to charge in the beginning, when it is at X, so all of the voltage is across the fixed resistor. So that will give us the maximum current. So we have the formula V is equals to IR. So I is equals to V divided by R. So voltage is 10 and the current is, the resistance is 5 kilo or 5000. So 0 will cancel with 0. It is 1 divided by 500. This will give us the maximum current which this capacitor can have. It's about 2 milliampere. And when we label the axis, we can work out the time constant. Like time constant is R into C. R is the resistance here, which is 5000, and C is the capacitance of this capacitor, which is 10 microfarad. So it is 50,000 divided by 1 million. So 0.05 means when it is at 37%, the time constant, it will be 0.05 second. And what is the 37% of the maximum value? Because the maximum current which entered is 2 milliampere. So 37% of 2 milliampere, that is 0.74. So this will be 0.74 into 10 to the power minus 3 ampere. That is the current after 0.05 seconds, because we work out the time interval for RC. RC means when it will discharge to 37%. So we have to label the axis. So the maximum value of the current will be 2. So this is 1 here. Like this is 2, this is 1, between 2 and 1, 1.5, and between 1 and 0, 0.5 will be there. And here we have a current and the unit is milli. ampere, and the time axis there like 0 0.01, 0 0.02, 0 0.03, 0 0.04, 0 0.05, 6, 7, and so on. And 0 0.01, 0 0.02, 3, 4, 5. So this is 0 0.05, 0 0.06, 0 0.07. So originally started with the maximum value, and after 0.05 second, its value should be 0.74. So somewhat here, like between, and when we join, and we should show exponential change, so it will be a curve. Is it clear, this graph for discharging of the capacitor? The next part after completing the graph, describe how the graph would appear when a switch is moved back to X. Like now it is start to charge, because when at Y it was discharging, but now at X it is charging back again. So what will happen to the shape of this graph? So the current will be in the things which will change here. The current, because the idea is that the current will be there on the negative axis, or the current will be in opposite direction. Graph will be same because charging and discharging graphs are same, but direction of the current changes. So we can say the graph will be same, but the direction of, or the current axis will be opposite, because the direction of the current is different for charging and discharging. Like if one of the current we say positive, the other current will say negative. So on the same axis, if we want to plot the graph, so then we should use both axes to show our charging and discharging. So this will be example. If it was a discharging graph, then the charging graph will be same but in opposite direction. Calculate the maximum energy stored in the capacitor. So energy stored in the capacitor is half base into height, or Q into V, and Q is equals to CV. So half Q into V and Q is CV. So we can substitute energy stored. It will be half, and in place of Q we write CV, so it will be CV square, where C is a capacitance, so that is 10 micro, and V is a voltage across the capacitor, that is 10 volts. So we always, like, even though the resistor is connected, the capacitor will charge when the current is passing, the capacitor will charge, and until the voltage of the capacitor is same as the voltage of the supply. That's why we took as a 10. But practically it won't be exactly 10. It will be less than 10. As you can see, there's also a fixed resistor present. So there will be some voltage drop across that fixed resistor until the capacitor is fully charged. So when the capacitor is fully charged, that moment the the voltage of the capacitor will be same as the voltage of the supply. So that's why we took as a 10. So this will give us 5 into 10 to the power minus 4 joules. Then the student used this circuit to produce a short time delay equal to it takes for a potential difference across the capacitor to fall to 0.07 second of its maximum value. Calculate this time decay. Like how much time it will take to decrease to 0.07 of its maximum value. So we have the formula for voltage, we have the formula for current. So we can use a voltage formula that V is equals to V naught e raised to the power minus T over RC. And what is V naught? V naught is a maximum, that is 10. What about V? 0.07 of its maximum. So 0.07 multiplied by of its maximum means like 0.07 of its 10. So 0.07 into 10, so we'll get 0.7. So the V is equals to 0.7. So this is 0.7. This one is 10 e raised to the power minus T. R and C. R is the resistance of the capacitor, that is in the beginning of the question given. That is 5000 and the capacitance is 10 micro. So this will be 5000 multiplied by 10 micro. So when we simplify, we'll take ln. So this will be 0.7 divided by 10 is equals to a raised to the power minus T over. So 50,000 divided by 1 million. 0.05, and then we take ln both sides. So ln 0.7 divided by 10 and this one is when we take ln both sides, it will be minus T over 0.05. So when we substitute the values for this, it will come out as 0.13. So T is equals to 0.13 seconds. Is it clear? Discussion?